Hello, guys. I just wanted to give you an open muscle update. This weekend, successfully created the LASK device, which is the label acquiring device. It is going to supply the label to the information that we get from Open Muscle. And so you see two different variations of the 12 sensor module. It's a 12 by 1 sensor where they're all in line, and then a 6 by 2 where they're stacked in cells of two vertically. The nice thing about Open Muscle is that it has rotational symmetry, so you might be able to glean enough data just from the sensor input what orientation it is. It does not have an accelerometer built in. It is meant just to see how accurate you can get with Hall effect sensors, pistons, for a muscle contraction detection system, how effective this label can be applied to regression. I don't think we'll do classification, but regression, machine learning, some deep learning, how many hours we're going to have to acquire. The roadmap is quite fun. So we're going to be working on for the label acquiring or the LASK systems. There's this physical system, which is based off of the tension on these springs. And again, Hall effect sensors with magnets, same type of sensor that's on the open muscle devices. Gonna be posting all that. There is already the raw input, the raw one that I uploaded this weekend, but gonna be getting the framework together so that all the data can be sent to a centralized location. Also, I want to embed it in video because you can do some other machine learning label assistance by using gesture recognition with the video that's taken and have the timestamp of the values. So the timestamps are on each device and over. So the packet starts, let's just start with the LASK device. It sends an actual dictionary, a string dictionary of the values as one parameter, the ticks and the processor, the NTP time if it can grab it. And so that will get sent to the central computer. The open muscle band will also do the same thing. It will send the number of CPU ticks. It will also send its local time if it can grab the NTP time or not. That does seem to fail about 50% of the time. I'll try to rectify that. And the collection computer, right now I'm using collectmuscle.py that's uploaded into the GitHub repository. That is taking both of those and saving them into a file, and it saves it sequentially into a file that also gets uploaded to GitHub every time I run it. So you can see the data live. I know Hackaday was kind of being cheeky when they said, hey, Turf, can we actually log into your Wi-Fi router? Yes, you can, because that's actually another device that I created just to be a middleman between this and the actual internet. So it's nice because these socket servers can traverse firewalls because we're using a port that's pretty high up and it's pretty normal looking traffic, nothing crazy about it. So even if you have a complex system, again, there's lots of refinement to be had in the future. I mostly just wanted to give you an update. There is a lot of stuff we're working on by we. Right now, it's just me. Some people have entered in ideas or submitted ideas, and that is wonderful. It's helpful. But it's not necessarily helpful is what I'm trying to get at. What's helpful is people that are willing to put in the time to test it out. So I haven't spent too much time documenting how to create one of these or this whole thing because no one has asked me to. So once I see the interest, I will start devoting some of my time, but more important is to create a whole infrastructure of code, hardware, software that people can use to capture machine learning data, right? And this data is then to be fed into machine learning to get the intelligible signal from the band. So ultimately, that's why this device is labeling it. So it says, hey, this finger is moving and it has to exert X number of newtons of force because to press in or depress this spring, compress this spring. And that is pretty helpful. So that value we're just assigning in between 0 and 1. 1 pressing down as hard as you can, 0 not pressing at all. So yeah, that's where we're at with Open Muscle. It's a wonderful new year. If you want to help in any way, join us. Again, it's all open source, all for free. Yeah. And so join the fun. Let's see how big. Let's try to make a positive dent in this world.